Okay, hello everyone. Today we're going to be looking at normal distributions and standard deviation. So standard deviation is a measure of spread. You could also look at variance as being another measure of spread. We won't be looking at how to calculate standard deviation today. However, we'll be looking at how we can use standard deviations in order to find out some information about the population or the spread of data. So within the first two standard deviations, so that means pretty much a standard deviation above the mean, which is denoted by mu plus 2 sigma, lowercase sigma. So with those two standard deviations there and two standard deviations below the mean, roughly 95% of the distribution is there. Says 95% in some publications, it may say 95.4% in other publications, but that's based on the empirical rule. If we're just looking at one standard deviation below and one standard deviation above the mean, then this actually houses approximately 68%. Sometimes you might see it as being 68.2%. Again, it's just depending on the publication you have. And then within free standard deviations, so free standard deviations below the mean and free standard deviations above the mean, that's where we have 99.7% of the distribution. Okay, so now that we've sort of segmented our distribution into 6 parts, 6 equal parts, because again, the standard deviation is some value. Don't know exactly what value it is, but they're always equal to each other. But because we've segmented it, we can now look at how much of the population, or what percentage of the population, falls within a certain category. So if we know that this bell curve here, which is generally what's used as a normal distribution term, because it kind of looks like one of the old-fashioned curved bells, if we know that this houses 68%, from the mean to the first standard deviation and from the mean to the other standard deviation, and we know that these are equal, then we can say that 34% are in both of those segments. So one standard deviation, from the mean to one standard deviation above the mean, we have 34% of our distribution. And we don't know exactly what values this mean is. It could be 100 or it could be 200, and the standard deviation could be, say, 5, so that would be 105 or 205, or the standard deviation could even be 120, making it 220, or it can be 120, making it 320. It doesn't matter, but we know that 34% of the distribution will be present between the mean and the first standard deviation above the mean. So it's a good way to get an indicator of spread and where quite a bit of the population lies. Because as you've probably noticed, one standard deviation below the mean and one standard deviation above the mean has a 68% of the distribution, a 68% sort of leeway of the distribution. So now, because of this, we can expand our knowledge and see, well, it's 95% for 2 standard deviations above from 2 standard deviations below. So if we were to denote this, we could say that mu minus 2 standard deviations to mu plus 2 standard deviations as 95%, sometimes 95.4%, depending on the publication you read. But in context, this means that this bit here will have 13.5%, and this bit here will have 13.5% of the distribution. And all these segments are equal in size. It's just, obviously, as you go along, you get less people in the distribution at that given point, or less whatever in the distribution. So if we add up all these numbers, 34 plus 34 makes 68, and then if we add 13.5 and 13.5 together onto 68, we would get 95 as well. And then remember that this one here is 99.7, so we've got to think about what percentage we could add to make that up. And the answer is, it'll be roughly 2.35% on either side. Again, it depends on what publication you read. but 2.35% there. And more importantly, what about beyond free standard deviations? Because free standard deviations may be pretty much all of it, but there still is a small section that we also have to account for, and this is roughly 0.15% on either side. And so we've looked at how we can break up a normal distribution based on standard deviations. So generally you'd say within free standard deviations below and above the mean, that sort of area in between there represents pretty much the entirety of the distribution, or almost the entirety, 99.7%. Okay, so now that we've had a look at how we can break up the distribution based on standard deviation, let's have a little look at some of these questions. So I'll just look at the first one, and it says, what is the probability? And a very important thing to note here is that probabilities are always between 0 and 1. But it asks, what is the probability of the distributed values lying between one standard deviation below the mean and one standard deviation above the mean? Okay, so as a probability, we know that 68% of it lies there, but we have to put it in between 0 and 1. So if we were to represent this as a decimal, it'd be 0.68. Because again, basically, if you're going from percentages like this to probability, then what you need to do is just put a 0 and you make it point that percentage. So it would be 0.68 is the probability of a value, a distributed value, lying between that range, between the range of, mean minus 1 standard deviation to mean plus 1 standard deviation. I know my mu symbols are terrible. Okay, so let's have a look at another one. And it says,